Hey guys, in this video I thought I'd show you guys how to basically start putting your data together and presenting it in a format that kind of really makes sense. So here you can see a nice graph depicting the VO2 max data for each of the different tests. In the previous video I showed you whether or not these were significantly different, and they weren't, so they're pretty much all the same. They tend to vary a slight amount, but that variation is not statistically significant. So how do you start making graphs that are representative of your data and kind of express what it is that you're seeing in a way that makes a lot of sense? So I kind of figured I'd show you guys how to do that. Remember, you guys are only comparing two specific values to each other. For example, if you're looking at critical velocity, so part of what you would have to do is to kind of assess whether or not the values are significantly different from each other. So I kind of figured I would show you guys how to make these graphs and how to depict whether or not significant difference is present. So go to your raw data. In this case, I'm just going to compare critical velocity values. So I'm going to take the critical velocity for the 25 meter and I'm going to take the critical velocity for the 50 meter. Control C to copy it. I'm going to paste it into a new worksheet. Just Control V and your values are there. You have to check the mean and standard deviation. So mean and standard deviation for your specific values. Remember, mean is just the average, and then you click and drag that down. Control close parentheses and enter, and standard deviation is equal to STDEV. You use the .s for sample, P is for population, so double click on that and then click and drag down, close parentheses and shift, and then you can just drag these across and you're done with that side of things. The other thing that you'd want to do is maybe check the extent to which these values correlate. Do your F test to see if the variance within these is the same or different, but that's not going to tell you whether these values are statistically significantly different from each other. That's where you do your T test. Remember, your F test is to tell you which T test you have to select, and then once you've done that, you can start making your graphs, right? So the only problem with Excel is it's a little bit tedious to make those column graphs. So part of what you need to do is you copy the titles and you kind of paste it where you want to put the data. You have to right click and then transpose. It just instead of making it horizontal, it makes it vertical. The same thing with this data. If you just Control C and transpose, it's going to give you this reference value, which is really annoying. So what you have to basically do, because of the fact that this is based on formulas that we've taken from above here, what you'll do is you Control C your values, and then you can just click anywhere, right click and do this paste special for values. Now it's just taking it as numbers. You can Control C that and then transpose those values, right? I did say it was a little bit annoying. Right click, paste special, Control C, transpose. So this is your mean and that's your standard deviation. Alright, so now you can highlight all of that. You can click insert and column graphs. Okay, let me just undo that for a second. I don't need the standard deviation in there yet. I'm just going to click those mean values, insert, column graph, and there we go. That's a lot better. So now we're going to just basically clean this up. I can get rid of the chart title. I'm going to delete that, give us a little bit more space. I'm going to add the standard deviation, the error bars on top. So you just click on one of the bars. That should highlight both of them. You can then go to the ribbon over here to the design tab, then click chart element, add error bars, more error bar options. You'll come to this screen over here, look for custom, specify value, and then we're going to highlight both of these. Press enter. Same thing for the negative values, highlight both of these, press enter, click OK. And now it's added our error bars. Then we can close this for now. I'm going to delete these horizontal lines. You can see here that these bars are quite far apart, so I'm just going to make it a little bit smaller, and I'm going to decrease the gap between them. Right click, format data series, and you should come with this series options, and then gap width you can play around with a little bit, make it a little bit smaller. It makes the bars a little bit fatter, but that's fine. Then also what I'm going to do is just kind of change the color scheme. So go to your paint options, we're going to go to fill, solid fill, and then choose white for now. It's going to make both of them white, that's fine. The border, I'm going to make a solid line and make it black. Okay, then I'm going to click, whenever I click on one of the bars, it's going to highlight both bars. I just press the one bar again, and then again I'm going to choose fill, solid fill, and then I'll make it a kind of a darker gray color, so to differentiate the two, and that's fine. I mean, you can choose whatever colors you want. I'm just trying to go for a little bit more of a professional look. I'm also going to put this horizontal axis on here. So in order to do that, I have to put a solid line. I'm going to make it medium gray, and that should give me that line over there, so that's good. I'm going to get rid of this border, so if I look at for the outside border of the graph, I'm going to put no line there. That's just going to help me copy and paste it a little bit later. I'm going to highlight all of this and make it white. So when I want this graph in my Word document, I can just copy and paste it as a picture. I'm going to put the x-axis title on here, so that's going to be VO2 in liters per minute, and then I'm going to make it bold, and this is going to tell you what we are specifically looking at. The other thing is there a statistically significant difference? We've already done that test, so I'm just going to insert a text box above this one over here and just put an asterisk in there, and I'm going to try and align it in the middle. You'll notice that there's a little box around it which I want to get rid of, so I click on that box, and then I look for line, and I don't want a line around it, so there we go. What I would then do here at the bottom is put the asterisk and say p-value less than 0.0001, because that's what we had. It's actually 0.001, so we say that there's a significant difference between these two values at the alpha level less than 1%. So what we can see here is that on average the critical velocity values from the 50 meter 3MT were significantly higher than those of the 25 meter 3MT. Part of your literature then is going to start unpacking that and would start saying, well, why are the VO2 values significantly higher? Oh, sorry, this isn't VO2 values, this is 3MT values. So your title over here should say critical velocity in terms of meters per second. Hopefully you guys picked that up already. So it's saying, why is your critical velocity significantly higher than during the 50 meter 3MT than it is during the 25 meter 3MT? We're going to try and unpack that a little bit more in other videos. But yeah, this is just how to make your graphs for now, so hopefully that's made sense. You would do this for a whole bunch of variables. Anything that you find is significantly different from each other, depending on what it is that you're looking at. So it could be VO2, it could be D prime, it could be total distance covered, etc., 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 and we report that in your results section. Alright, see you guys in the next video.